and noise air pollution caused by vehicle emission, industrial activities, and construction dust leads to dangerously high level of PM 2.5 particles and toxic gases like nitrogen dioxide. These pollutants worsen air quality, increasing the risk of respiratory disease, heart conditions, and reduced lung function, especially for vulnerable groups. Pure air circulation in winter traps pollutants, making the problem worse. Rooted in earth science concepts like atmospheric pollution and air composition, this crisis affects public health and highlights the urgent needs for solutions to reduce exposure and improve Hanoi's air quality. Our company aims to protect public health by developing advanced face masks with zinc oxide, which neutralize toxic gases and filter harmful pollutants in Hanoi's deteriorating air quality. As a leader in the health and environmental protection industry, we integrate scientific research, product innovation, and strategic marketing to offer superior air filtration solution as zinc oxide. We ensure workplace and public safety by providing comprehensive service, including risk assessment, safety training, personal protective equipment, and emergency planning. We are committed to create safer workplace, reducing risk, and foster a culture of safety, helping organizations meet safety standards and protect their most valuable asset. Our manager oversees business operation, product development, and partnership, requiring a PhD in business, environmental science, or material science, with expertise in research-driven product management. The researcher holding a PhD in chemistry, material science, or environmental engineering focuses on zinc oxide research, improving filtration efficiency, and ensuring compliance. The marketing specialist responsible for driving campaigns, public education, and brand strategy utilize market research and digital outreach to promote our mask effectively. No formal degree required, but experience in marketing, business, or communication is preferred.
Air pollution in Hanoi makes people feel uncomfortable to going outside. A face mask should help them feel better and safer, right? Sadly, no. For example, many masks only block dust, but toxic gases like sulfur dioxide and nitrogen dioxide still pass through. That's why we created a Xenox face mask, designed not just to filter, but to neutralize harmful pollutants. Compared to activated carbon masks, Xenox goes further. Sulfur dioxide, nitrogen dioxide, activated carbon only traps it for a short time, but Xenox breaks it down under UV light for better air quality. Xenox also have antibacterial properties, keeping the mask cleaner for longer. And lastly, activated carbon lose efficiency, but zinc oxide keeps working by reacting with pollutants instead of just trapping them. So why settle for outdated protection? The Xenox face mask doesn't just filter, it neutralizes toxic gases and fight bacteria, giving you real long-lasting protection.
Now we'll head into our company's laboratory to do our experiment. We'll meet our chemist, Nhật Minh.
Hey everyone, I'm Nhật Minh.
The first experiment we're doing here in this laboratory is actually quite dangerous, as it involves the production of this gas called nitrogen dioxide, which we'll be testing out whether or not the zinc oxide will actually work on removing this air pollutant. This is why we're working with lab coats on, goggles, gloves, or wearing a mask and working a proper fume hood. To generate some of this reddish brown gas, we simply need some metallic copper and some 68% nitric acid. As the pieces of copper are dropped in the conical flask, the clear solution immediately turns green due to the copper-2 nitrate complexes that's formed, and evolution of a reddish-brown gas is observed. The stopper was put on, and a delivery tube was attached to it to control the NO2. After some unsuccessful attempts, we decided to just lead the gas into a test tube with fine zinc oxide powder spread around. That was our first experiment. Now, to actually confirm we made the zinc oxide absorb the NO2 and make zinc nitrate, we need a second experiment. The first step is to dissolve the treated zinc oxide in some water, shake it around, letting the excess zinc oxide settle, and collecting the water part in another test tube. We have prepared a reagent for the brown ring test, a mixture of iron 2 sulfate and concentrated sulfuric acid that we'll be pouring into the solution. In theory, the iron 2 should be oxidized to iron 3, contributing to the brownish yellow color of the solution made. And indeed, when we added a mixture to the suspected nitrate solution, what was colorless before immediately altered yellow, which confirms the presence of nitrate ions in solution, meaning that the zinc oxide was able to absorb and react with the nitrogen dioxide, causing air pollution.
So the sustainability of our solution have three main points: social impact, environmental impact, and economic impact. For the social impact, we have health protection, awareness, and community support. And for environmental impact, we have waste production, eco-friendly material, and less plastic. And lastly, economic impact, we have cost-effective healthcare with savings and green investment. That's the end of our sustainability. And for the strengths and obstacles, we have advanced protection, long-lasting, antibacterial, and eco-conscious. For the challenge that we might have faced has government approvals, compliance, and import-export. But don't worry about the obstacles. We have solutions. Government approvals, collaborate with agencies, provide clear data and conscious experts. And for compliance, align with standards early and invest the legal support and conduct audits. For import-export, partner with logistic firms, streamline documents, and adapt to regulations.